Students, today we are going to do neighborhood of a point. A set S subset of reals is said to be neighborhood of a real number P if there exists an open interval P minus epsilon P plus epsilon for sub epsilon greater than 0 such that P is contained in P minus epsilon P plus epsilon, which is again contained in S. Then this set S is called neighborhood of real number P. इसी डेफिनेशन को हम एक तरह और किस तरह से बोल सकते हैं, कोई भी सेट S जो सबसेट है रियल्स का वो नेबरहुड होगा रियल नंबर P का इफ़ देयर एग्जिस्ट सम ओपन इंटरवल AB such that P is contained belongs to AB and it AB further contained in set S. अब कुछ एग्जाम्पल्स समझाने के लिए कि आपको कैसे किसी पॉइंट का नेबरहुड बताना है. द ओपन इंटरवल AB इज नेबरहुड ऑफ ऑल ऑफ इट्स पॉइंट्स. अब नेबरहुड AB में किस तरह के पॉइंट्स होंगे? वो सारे रियल नंबर जो A से बड़े और B से छोटे होंगे. अब अगर हम कोई रियल नंबर x ले लें तो x इज कंटेन्ड इन AB एंड AB इज अगेन कंटेन्ड इन set AB. So AB is neighborhood of real number x which lies between AB. अब x हम कोई ऐसा रियल नंबर ले लें जो लेस देन और इक्वल टू a है. सपोज x a ही है तो a जो पॉइंट है दिस लाइज इन ओपन इंटरवल a माइनस एप्सिलॉन एंड a प्लस एप्सिलॉन विच डज नॉट कंटेन in open interval AB. So open interval AB is not a neighborhood of real number x which is equal to a. और अगर x less than a है तब भी x किस में कंटेन होगा? x माइनस एप्सिलॉन और x प्लस एप्सिलॉन किसी ओपन इंटरवल x माइनस एप्सिलॉन और x प्लस एप्सिलॉन को बिलोंग करेगा x. और ये जो ओपन इंटरवल है x माइनस एप्सिलॉन और x प्लस एप्सिलॉन इज नॉट कंटेन्ड इन AB. सो AB इज नॉट अ नेबरहुड ऑफ एनी रियल नंबर x विच इज लेस देन a. नाउ इफ वी टेक अ रियल नंबर x विच इज ग्रेटर और इक्वल टू b. अब अगर x इक्वल टू b ही ले ले तो b इज कंटेन्ड इन b माइनस एप्सिलॉन एंड b प्लस एप्सिलॉन. But b minus epsilon and b plus epsilon is not contained in AB. So open interval AB is not a neighborhood of real number x which is equal to b. Now if x is greater than b, then x belongs to an interval x minus epsilon x plus epsilon, but x minus epsilon x plus epsilon is not completely contained in open interval AB. So अब इसमें x माइनस एप्सिलॉन और x प्लस एप्सिलॉन में होगा क्या? क्योंकि x जो है वो ग्रेटर देन b है तो इट कंटेन्स ऑल द पॉइंट्स विच आर ग्रेटर देन b. सो देयरफॉर x माइनस एप्सिलॉन एंड x प्लस एप्सिलॉन इज नॉट कंटेन्ड इन ओपन इंटरवल AB. सो AB is not neighborhood of all the real numbers which are greater than b and equal to b. So this is clear. We have discussed if x lies between a and b, then ax belongs to an open interval AB which is completely contained in AB. Again, if x is less than or equal to a, then AB is not an neighborhood of real number x which is less than a. And if x is greater than or equal to b, again AB is not an neighborhood of all real numbers which are greater than or equal to b. So open interval is neighborhood of all the reals which lies between AB. तभी लिखा हुआ है the open interval AB is neighborhood of all of its points only. Next example is the closed interval AB is neighborhood of all of its points except A and B. So again on the same concept, if we take a real number x which lies between AB, then x belongs to open interval AB which is completely contained in closed interval AB. So closed interval AB is neighborhood of all real numbers which lies between A and B. Similarly, if x is greater than or equal to A, then closed interval AB is not neighborhood of all real numbers which are less than or equal to A. For example, if x is less than A, less than or equal to A, then x lies between x minus epsilon and x plus epsilon, which is not contained in closed interval AB, because x minus epsilon and x plus epsilon contain all those points x which are less than or equal to A. So therefore closed interval AB is not neighborhood of real numbers which are less than or equal to A. Similarly, if we take x greater than or equal to B, then x lies between x minus epsilon, x plus epsilon. So it contains all those real numbers x which are greater than or equal to B. So it is not contained in AB, closed interval AB. So therefore closed interval AB is not a neighborhood of all the real numbers which are greater than or equal to B. So the closed interval AB is neighborhood of all the points except points A and B. Using the same concept, we can say that half open interval AB is neighborhood of all of its points except A. Now, a non-empty, fourth example, a non-empty finite set is not neighborhood of any real number. इसको हम कैसे प्रूव कर सकते हैं? सपोज हम मान लेते हैं कि ये जो फाइनाइट सेट A, कोई भी फाइनाइट सेट A है, and let x be any real number. If A is neighborhood of this point x, तो क्या होगा? जो x है, according to definition of neighborhood, x belongs to some open interval AB, and this open interval AB is contained in A because A is neighborhood of x. So x belongs to open interval AB and AB is contained in finite set A. अब जो ओपन इंटरवल्स होते हैं या क्लोज इंटरवल, कोई भी इंटरवल अगर होगा तो वो उसमें कितने पॉइंट्स होंगे? दैट इज हैविंग इनफाइनाइट पॉइंट्स. सो कोई भी सेट जिसमें इनफाइनाइट्स पड़े पॉइंट्स हैं वो किसी भी फाइनाइट सेट में कैसे कंटेन हो सकता है? सो therefore there does not exist any x belongs to open interval AB which is further contained in A. So any finite set is neighborhood of any real number x. Similarly, on the same pattern, कोई भी finite set 1 2 3 किसी भी real number का neighborhood नहीं हो सकता. कैसे लिखेंगे? Let x be any real number. So x belongs to a open interval, an open interval x minus epsilon, x plus epsilon, but this open interval x minus epsilon, x plus epsilon, which contains infinitely many point, does not contained in 1 2 3 finite set 1 2 3. So any finite set 1 2 3 is not neighborhood of any real number x. Similarly, any set of natural number is not neighborhood of any real number x, because if we take x any real number, x belongs to x minus epsilon, x plus epsilon, an open interval which is not contained in naturals, because x minus epsilon, x plus epsilon contains infinitely many reals. On the same pattern, we can prove the set of integer is not neighborhood of any real number. If we take any real number x which belongs to x minus epsilon, x plus epsilon is not completely contained in set of integer. Similarly, set of rationals is not neighborhood of any real number. So I think neighborhood clear. Now what is deleted neighborhood? Firstly, we take definition. Deleted means जिस पॉइंट का हमने नेबरहुड लेना है उसी को उस ओपन सेट से एक्सक्लूड कर देना है. द सेट p माइनस एप्सिलॉन p प्लस एप्सिलॉन एक्सक्लूडिंग p इज कॉल्ड डिलीटेड नेबरहुड ऑफ P। मतलब उस पॉइंट P को छोड़ के आपके पास जो सेट में रिमेनिंग एलिमेंट्स हैं उसको हम बोलते हैं डिलीटेड नेबरहुड ऑफ P। नाउ सम थ्योरम्स बेस्ड ऑन neighborhood. A superset of neighborhood of a point P is also neighborhood of P. अब superset को कैसे हम प्रूफ करेंगे? अगर कोई A सेट हम ले लेते हैं, लेट सेट A be neighborhood of point P. So if A is neighborhood of point P, then there exists epsilon greater than 0 such that P belongs to P minus epsilon, P plus epsilon is contained in A. ठीक है, अब B सुपरसेट है A का, सो A फिर से कंटेन होगा B में, तो होगा क्या? P belongs to P minus epsilon, P plus epsilon contained in A and A is further contained in B. So अगर हम कंबाइन करके इसको पढ़ें तो we will read this as P belongs to P minus epsilon, P plus epsilon which is contained in B. So this show that B is neighborhood of P. Next theorem. If sets A and B are neighborhood of P, then intersection of A and B is also neighborhood of P. How will we prove? हमें given क्या है? A और B जो है वो neighborhoods है P के. So we will take epsilon 1 and epsilon 2 greater than 0 such that, अब अगर A neighborhood है P का, so P belongs to P minus epsilon 1, P plus epsilon 1 which is further contained in A. For some epsilon 1 greater than 0. Similarly, P belongs to P minus epsilon 2, P plus epsilon 2 which is contained in B. Let us take some epsilon which is minimum of epsilon 1 and epsilon 2. अब epsilon जो होगा वो उनका minimum हो गया. अब P minus epsilon और P plus epsilon जो हमारा neighborhood है, जो हमारा interval है, वो किस में contain होगा? P minus epsilon 1 P plus epsilon 1 में भी, और किस में contain होगा? P minus epsilon P और P plus epsilon P minus epsilon 2 में भी, that is contained in